Hey everyone and welcome. Today, we're jumping headfirst into a topic that is absolutely essential for your WAEC, JAMB, and NECO exams, motion. I promise, by the end of this, you're going to have a solid problem-solving toolkit to handle pretty much any motion question they can throw at you. Alright, let's get right into it. So first things first, what even is motion? It sounds complicated, but it's not. It's just a change in where something is over a certain amount of time compared to its surroundings. You know, a car driving, a planet orbiting the sun, it's all motion. Getting this simple idea down is literally the first step to crushing those exam questions. Okay, now to solve these problems like a real pro, you need the right tools. So think of this next part as us opening up a toolbox and filling it with every single key concept and formula you're going to need. Let's start building your ultimate physics toolkit. You know, motion isn't just one single thing. It actually comes in a few different flavors. You've got translational, which is just a fancy way of saying moving in a straight line, like a car on a highway. Then there's rotational. Think of a spinning wheel. Oscillatory is that classic back and forth swing of a pendulum. Circular and orbital motion, that's what planets and satellites do. And finally, you've got random motion, kind of like how dust particles just zip around all over the place. Alright, pay close attention here. This is a big one, and it's a spot where a lot of people trip up and lose easy marks. What's the deal with scalar versus vector? It all comes down to one simple word, direction. A scalar just has a size or magnitude, like say 50 km per hour, but a vector has that size and a direction, 50 km per hour going north. So the big takeaway, you've always got to watch out for direction. Let's add another crucial tool to our kit, acceleration. All this is the rate at which an object's velocity changes over time. So if you're speeding up, that's positive acceleration. And if you're slowing down, well, that's just negative acceleration, or what we sometimes call deceleration. Simple as that. And here they are, the absolute superstars of our toolkit. These four equations are going to be your best friends for any problem with uniform acceleration. Just remember what each letter means. U, V, A, S, and T. They are all there to help you solve for initial velocity, final velocity, acceleration, displacement, and time. Mastering these is a total game changer. Now, sometimes the examiners won't just give you numbers, they'll give you a graph. But don't worry, these are actually shortcuts. For a distance-time graph, the steepness, or the slope is just the speed. And for a velocity-time graph, the slope is the acceleration, and the area underneath the line, that's the displacement. It's a visual way to solve problems, and examiners absolutely love them. Okay, our toolkit is officially built. We've got our definitions, our key formulas, and we know how to read the graphs. Now for the fun part. It's time to put these tools to work on some real past questions from WAEC, JAMB, and NECO. Let's see how it all fits together. So here's our first challenge, pulled straight from an old WAEC paper. Take a good look. See that key phrase, move off together. That should be a massive clue about which tool from our kit you need. So go ahead, pause right here, grab a piece of paper, and see if you can solve it. Alright, let's walk through it. This is a classic conservation of momentum problem. Because the two balls stick together after they collide, we know that the total momentum before the crash has to equal the total momentum after. So we calculate the initial momentum, which is really just the first ball, since the second one was just sitting there. That gives us 5. For the final momentum, the two masses combine and move off with a new velocity, v. We just set them equal to each other and solve for v. And there it is. The answer is D, 5.0 meters per second. The pro tip here is to always look for those keywords. When you see stick together or move off together, your brain should immediately scream conservation of momentum. It's a huge clue. Okay, next up, a JAMB question. This one is all about circular motion. We've got a particle on a fan blade, and they give us the mass, the angular velocity, and the radius. They want the centripetal force. This is your chance again. Pause the video, Find the right formula in your toolkit, and give it a shot. So how do you do? The trick here was picking the easiest formula. Since they gave us angular velocity, that little omega symbol, omega, we should use the formula F equals m omega squared r. After that, it's really just plug and play. We put in our mass, our omega, our radius, and let the calculator do the work. And the answer is B, 20 newtons. Here's a pro tip that does save you precious time in the exam. Work smart, not hard. Sure, you could have converted the angular velocity to linear velocity and used the other formula, but why? That's just an extra step where you might make a mistake. Always use the tool that fits the job perfectly. Okay, our final practice problem is from NECO, and this one is a bit tricky. Notice that the ball moves off in the opposite direction. That's a super important detail. This is your last chance to pause and put that toolkit to the test. Go for it. So let's see how this one gets solved. This is a job for our impulse momentum tool. We know that force times time equals the change in momentum. But here's the critical part, getting the signs right. If we call the first direction positive, then the opposite direction has to be negative. That means our final velocity is negative 25 meters per second. That gives us a final momentum of negative 2.5. Once you have that, you just plug everything into the formula and solve for the force. The math gives us negative 225 newtons. But wait, the question asks for the magnitude of the force. Magnitude just means the size, so we can ignore the negative sign. The answer is E, 225 newtons. This problem is the ultimate test of whether you're paying attention to vectors. Forgetting that sign change is the number one mistake people make here. Fantastic job walking through those. We've built our toolkit and we put it to the test. Now let's just boil everything down into a final super handy cheat sheet you can use to prep for the big day. Okay, here are the absolute must-know formulas. We have our basic linear motion equation, the range formula for projectiles, the centripetal force for circular motion, the period of a pendulum for simple harmonic motion or SHM, and of course the big one that started it all, Newton's F equals ma. Having this locked in your memory is half the battle won. And finally, just some pure exam strategy. Seriously, always draw a little diagram. It helps so much. Be paranoid about your units and your plus or minus signs. If you're writing an essay answer, show your steps. For multiple choice, knock out the obviously wrong answers first. And if you have time at the end, please double check your math. And that's a wrap. That is your guide to acing motion on your physics exams.